Welcome to ADF Insider. My name is Frank Nymphius and I'm from the Oracle Application Development Tools Product Management team. In this session we're talking about ADF binding internals. As you can see from the slide, this is part 2 of a series that talks about binding internals. This session focuses on the binding runtime behavior and the runtime objects that are created. In the previous part, we introduced the metadata that you work with at design time. We introduced the page definition file, the data binding CPX file, as well as the metadata that is generated and used to configure data controls. The ADF architecture consists of 3 parts. There's a view technology part that renders the page. There is a business service part that executes business logic and queries the data, and there's the binding that dispatches between the view and the business service. On the binding we find the ADF binding layer and the data control layer. The data control layer understands how to talk to the business service, no matter what the business service is, if it's business components, web services, POJOs, or enterprise Java beans. The data control layer is responsible for talking to the business service APIs to dispatch the application request, be it a query, an update, insert or delete operation, to the business service model. The ADF binding layer, colored with a red background, is the connectivity between the data control and the user interface component. So the binding layer is responsible for showing data in the user interface component. On the view layer, the preferred technology that Oracle uses within the Fusion stack is Java Server Faces. For that we have ADF Faces component model, which is a rich internet application environment, DVT for graphical data, and we do have components for desktop integration that would allow you to access the ADF binding layer from Microsoft Excel. The responsibility of a binding layer is first to prepare the model. So when a request comes in for a page, then the data for the page needs to be queried and it needs to be prepared so that when the request comes back with an insert and update, the model is ready to perform that task. In addition, whenever you execute operations that are exposed on the business service, you do so through the ADF binding layer, and you do this for a reason. And the reason is that the binding layer refreshes the related components that need to be refreshed in response to an operation. Operations that by default are exposed on the data control are next record set, previous record, commit, rollback, and so on. Methods are custom methods that you expose on the business service. So this is related to the use case that the business service implements. That could be relocate employee or hire new employee, whatever suits the use case. The managed row currency is the main in the binding layer to have one record being the current record. So whenever a user selects a table row or a tree node, selects on it, then in the binding layer the selection is set as the current row, which also means that if you select a table on the UI, you can get the associated table row object, the data representing the row that the user selected, on the binding layer, so you don't have to necessarily go back to the table itself. The main responsibility though is of the binding layer to provide a simplified business service access through a consistent set of APIs. As you could tell from the previous slide, the ADF binding layer abstracts the business service so that an application developer who builds the application doesn't need to know about whether the business service he or she is accessing is a ADF business components, EGB, a POJO, or web service. So they all work with the same consistent API. So once you understood how to work with the ADF binding layer, you're good to go with any kind of business service. The first time you drag and drop an ADF component from a data control panel onto a page, the web XML file of the project is updated with the ADF binding filter. The ADF binding filter ensures that with the incoming request for a Java Server Faces page, that the binding context of the ADF binding is created, is initiated, so that the ADF data and the ADF lifecycle is started with the lifecycle of the Java Server Faces page. As you see, the filter is mapped to the Java Server Faces servlet, so whenever there's a request for the Java Server Faces page identified by default with a /faces in the request path, then the ADF Faces lifecycle and the ADF binding lifecycle will also start. This slide gives you an overview of a request flow when it comes in. So first thing is that the ADF binding filter prepares the binding context. As you may know if you're experienced with Java Server Faces, the Java Server Faces lifecycle has 6 stops. It starts with recreating a view. So if it's the second time that a specific page is called, then in-memory objects for a specific page exist. These are then resolved and the state that is kept on the server is recreated so that any value that comes from the client in form of an update, for instance, can be applied to the existing object. The second stop is the apply request values. The third stop is validation, and the next stop then is where the model is updated. Now in the Java Server Faces world, the model typically is defined in a managed bean. In the IDF case, ADF represents the model. So when we reach the JSF update model phase, then the ADF binding gets updated. And then it continues with the JSF invoke application phase and then with a render response phase. The ADF page lifecycle that you see next to the JSF lifecycle has a bit more steps to go through than the normal JSF lifecycle, but this is well synchronized with the JSF lifecycle. In fact, it's integrated. The binding context you see on the view side knows about all the page definition files and all the binding containers. So this is a representation, the live representation of the data bindings CPX file that we introduced in the first part of this series. The binding container is the live instance of the definitions that you provide in a page definition file. The binding container instantiates objects, live objects, of all definitions defined in the page definition file. If a binding container has a reference to another binding container, which could be the case if you're working with templates, or if you have an ADF region that has a task flow binding reference to another binding container, then all this information is part of the current binding container and can be accessed from that. Also, a definition in the binding context is the data control that is used. You can have a page using more than one data control, and all the data controls are defined within the data binding context and referenced in the binding container. So let's start with the incoming request. So first of all, we need to set up the binding context, which is achieved through the binding filter. The data control that is referenced within the binding container is looked up through the binding context and instantiated. This then accesses whatever the business service endpoint is. That could be an application module if the business services application business components, ADF business components. That could be a POJO session facade, that could be an EGB facade, or that could be a WSDL reference in a web service case. When we get the data control handle, we start initiating the request. The first request goes straight to the data control to initiate, to query the business service, and then the rest of the operation goes through the binding container. So we look up what is the binding container associated with the page, and this is identified through an entry, through a mapping in the data binding CPX file that we introduced in the last session. What you can see in this diagram is that building or querying the data for a specific page is not done within a single request. In fact, it's a deferred loading where we issue additional requests. So we deliver the data in chunks, which is the default setting. Now the benefit of this is performance. We are able to render the page while we're still fetching data, which allows the user to see the data coming and being rendered even before all the data is present. This is a configuration that you can change in the page definition file. The default behavior is a deferred loading, but you can also define that the model should be prepared to a specific time, in which case it will fetch all the data. You will have to wait a bit longer, but then you have all data on board. And at the very last end, we render the response, and after rendering this response, the data control is released, and with the release of the data control, the application module is also released. Now in the ADF Business Components case, if you use ADF Business Components as a business service, the release of the data control will release the application module. If you have application module pooling configured, then the application module will be given back to the pool of application modules and wait for the next request. If the same request comes from the same user, then if the application module is still around, it will be given back to this user. If the application module is no longer around, then from its passivation state, the instance of the application module is recovered, so that the user always works within the same context of the application. So he always comes back, even though the web is a stateless environment, the user comes back and finds the same state of the application module. Similar for web services and for POJOs. So, what are binding doing within Java Server Faces if we take the example of Java Server Faces? Well, first of all, Java Server Faces is a component model. So every UI component has a Java object on the server. And then the binding also at runtime is in Java an object. Only at design time bindings are metadata files. At runtime they're all Java objects. And the next slide show you how the binding work within Java Server Faces. This slide shows the Java Server Faces component model architecture. So on the example of ADF Faces, where we have a client-side and a server-side model, the server-side model uses expression language to bind the user interface component, say a text field or a table or a tree, with the component model. And the component model is responsible for querying the data, fetching the data, and bringing the data into a structure well understood by the component. Typically, the component model is defined in some POJO. That could be a managed bean or a helper class that you build and reference from a managed bean. The pure non-ADF implementation uses Java classes, managed beans, to query the data to access the business service. So for you as a developer, the simplest component model would be a setter and a getter pair. That is something you can use with output text components, input text components. The more complex components like trees and tables require to implement a lot of methods and APIs just to make the tree and the table work, including the row currency, the set current row, and so on, and the expand behavior. Now this is a lot of work to do, and many developers not working with ADF spend a good portion of their time not building the application but building the component model so that the component model behaves right. The next slide shows you how ADF hooks into this. As you can see, ADF provides a component model for the components. So in ADF we have binding classes that know how to talk to the data control, and the data control now talks to the business service. So as a developer, you no longer talk directly to the business service, but you deal with the binding, and the binding is linked to some business service. So at least the web application developer no longer needs to know about the business service, because he or she will see a consistent set of APIs that allow to query, insert, update, and so on. The part that is responsible for providing the component model in Java Server Faces are extensions of the generic data binding classes, and these extensions all start with a faces control in the name. So if you look into the Oracle ADF source code or in the Java docs, you will see classes called faces control here binding, faces control address binding, faces control list binding. Now these classes extend the generic binding classes to provide additional functionality needed by the component. For the application developer, that means that you just build your application. You no longer have to think about building the component model first. And this is the great advantage that ADF brings, because it takes away the burden of building the gluing between the user interface and the business service. Now, I said that at design time you use metadata, but you don't use metadata at runtime. Well, in fact, this is halfway true, because what happens at runtime is that the metadata definition that you build at design time is parsed, is looked up, and then it is used to configure a Java object. And this Java object is used at runtime to communicate between the component, the user interface component, and the business service through the data control. Binding classes that we have in ADF are defined or configured through XML at design time. There are two types of binding classes. There are generic binding classes, which are the parent of different user interfaces. So if you have a Swing application and you use the binding, then you use the same generic binding classes to access the data control. And then we have specific binding classes which are specific to the view rendering. Now in Swing we do have ADF Swing, which is a specific set of binding classes that extend to generic binding classes. In ADF Faces, as mentioned, we do have Faces control bindings, which are specific classes extending the generic binding classes. All generic binding classes start with JU control. So JU control identifies a generic binding class. The additional functionality provided by Faces control bindings are, for instance, as we show here in the slide, the make current method that is used on the table on a tree to translate the user selection in the component to set the current row in the binding. So there's a method called make current on the Faces control binding. And the reason why this is there is to make it expression language accessible. And if you now turn into your JDeveloper, if you have a table that you drag and drop on the page, then you will see a selection listener configured with an expression language pointing to the binding layer, pointing to your tree binding, pointing to make current. Developers that use Java to access the binding layer, and this is a approach beside of using expression language to get data from the binding or to interact with the binding. Developers that use Java for this interaction typically don't work with the full set of classes. A lot of classes in the binding layer are used internally by the framework and not really are required to be used by application developers. But there's a common set of classes that I like to introduce so that you know what these classes are doing and what they're good for. Before getting there, why at all do I want to access ADF bindings from Java if I can do the same in expression language? Very good point here. And we do promote declarative development. And as I mentioned, the expression language is used to access the same Java methods as you would do in Java. So you can say that declarative development in fact wraps the Java APIs. So only because you're developing declarative, it doesn't mean you're not using Java, because it's a Java development environment that we are within ADF. It's a recommended first approach, and it makes a lot of things easy. One thing that's easy is an upgrade from one release to the next release, because if there are changes in the API, then these changes can be catched, because expression language always points to changed classes then, in which case the vendor, Oracle, will make sure that the upgrade path works nicely and fine. Now if you use Java for the same job, then it could be that if there's a method that gets deprecated, this will be flagged, but this will reflect as a warning and you will have to do it manually. So this is why declarative development always is the first choice for developers. But then declarative development always works with properties. It puts a single entry into a property field like a selection listener. Now what if you need to execute two listeners in a row? If you have the need to, on row selection, not only to execute the make current method, but you want to also execute some other code. Now this is where you start getting into a requirement that makes you building your own listener for that. And this typically you do in Java in a managed bean. But then to preserve the functionality that the ADF binding layer provides, you need to code that. So you would have to manually access the ADF binding layer, the ADF binding objects at runtime to achieve the same functionality that expression language is providing. One example I have, and that I want to show you, is where I needed to control the order of execution. So I have a synchronization between a tree and a form, and I need to make sure that the form actually is changed to a time before the data is refreshed using partial page rendering. So for this, let me switch to my example application. This is my example. On the left hand side I do have a tree, and on the right hand side I do have an input form that is synchronized with the current selected row or node in the tree. So I can update the selected node. But if I expand the tree and click on administration, then what you see, first of all, the data now shows the data for administration, but you also see that there's a change in the input form because there are additional fields. Some of the fields are only read-only because I'm not allowed to edit them. It's more obvious if I go to the next level. Here you see that additional fields are displayed. So the form, the input form that I have on the right hand side of the panel splitter behaves in accordance to the selection in the tree and the tree node. While I can build the tree and the tree nodes with declarative binding, I can also synchronize iterators that the input form is built on with declarative development approaches. But the synchronization between the selection to ensure that first the form, the form fields are changed and refreshed before the data is displayed, this is something that I enforce through Java. So I enforce the sequence in which the operation happens, and this is what I use Java for. We will go back to this example in a minute, but let's continue with slides to learn more about the binding objects. Here's a architecture or a class diagram view of the binding classes. Not all binding classes, so don't count them. There are a lot more binding classes in ADF than that. But this is a subset of classes that most likely you start working with when coding in Java. You see there's a blue rectangle, and I put text in there, ADF faces component binding. Now these represent the faces specific binding classes, and you see them pointing to generic binding classes like the faces control here, node binding points to the JU control here, node binding. Both represent a node in a tree. The ADF faces component bindings should not be used by application developers. They are packaged in an internal package, and you can see in the package name it's saying ADF internal. Now the reason for this is that these classes are specific, they're not generic, and they're not meant to be used by application developers. They're internal classes, and if there's a component change, say we are improving one of our components like a tree or a table, and that requires a change in the component API, then we do that, and we do that without further notice. You're on the safe side if you always use the generic binding, everything that starts with a JU control. If you now have a code review of your existing application, you recognize that you use faces control classes. My recommendation is to change that. Yeah, just plan to replace faces control usage to the general generic binding classes. So let's have a look. Here we do have a set of classes that are really typical to work with. These are the most commonly used classes. One class that doesn't have representation in the view layer project is the ADF context object. The ADF context object represents the live instance of the ADF config.xml file that you find in the .adf meta-inf directory of your application on the file system. This class doesn't really provide a lot of functionality that you want to work with, except for it exposes the security context just in case you're working with ADF security and you want to do some check permissions on an object, and it exposes the MDS object or the MDS session as an object if you're working with metadata services and you need to get access to the MDS object session. Beside of this, it's just representing configurations. The DC binding container or binding container interface, so DC binding container is an implementation of the binding container interface, represents the page definition file at runtime. As I mentioned, everything that you specify in the page definition file at runtime is enclosed in a Java object, and this Java object is a DC binding container. The DC binding container gives you access to all bindings, to all executable bindings, to all variables, to all parameters, and to all component bindings. You simply look the bindings up by the name. There are also, and we will see that on the slide, there's also an option to navigate within a binding container from accessing one of the contained bindings. So if I have a handle to the tree binding that provides the data for a table or a tree, then from there I can get to an iterator binding, or from there I can get to the binding container and can invoke methods on that. The binding context is the live representation of the data bindings.cpx file. This is the registry of page def files and also contains the references to the data controls used. The iterator binding helps you to browse through a collection of data. So it helps you to look up rows, to insert new rows, delete new rows if you wanted to do this in Java. All of the components binding, like attribute binding that you see there as JU control address binding or JU control list binding or hierarchical binding, they all reference the iterator binding. So everything is linked to an iterator binding, and the iterator binding then links to the collection that you queried from the business service. You see two icons for operation bindings. So we have operations and custom methods, and this is what you want to invoke if from Java, for instance, you want to call a custom method. So these are the objects, so just the object representations of what you see at design time in the metadata, and this is on the left hand side what you work with if you use Java, but what also is used within the expression language that you define in the design time. Let's go over some of the objects. But before that, I'd like to encourage you to have a deeper look into our documentation. The Fusion Developer Guide at the end has an appendix where we explain all the properties that belong to metadata structures within the pagedef file or within the data binding CPX file or data control files. And it's really worthwhile reading because the ADF binding layer provides a lot of functionality in its metadata that you can use to influence the lifecycle or just validation or some other aspects as well. So just to give you some examples, the page definition file has a customization section, and as you know, metadata services allow you to provide seeded customization for an application, so that when different users log in or when an application is installed on different locations, you have the ability to show different bindings or different application look and feel and functionality based on the user, based on the location. To prevent everyone messing up with the binding definitions, you might restrict who is allowed to do that, especially when you work with Web Center where you have design time at runtime. You may want to restrict who is allowed to change the binding, and this is what you can do with the customization allowed property. There's another class called the controller class, and for sure we should have, and I guess we will have in the future, another part of this ADF binding internal presentation that outlines the life cycle. But just to give you kind of a heads up here, the controller class property allows you to change the internal life cycle for this page. There's a lifecycle class, a page lifecycle class that you can override, and where you can influence for this page definition file how validation happens. You basically control or change the internal behavior completely if you want. It's not necessary to do that, but there are use cases where developers in the past found that useful to be able to do that and to change the life cycle for that purpose. Then there's actually two parameters. One is called the skip validation and the other one is called the custom validator. The skip validation is set to false by default, which means that with every request that comes in within the Java Surfaces lifecycle, we perform a full validation of the ADF model. If you changed different data controls with different data, then the full set of data controls that has been changed will be validated. Now this could be an unwanted behavior, especially if you have a wizard that steps users through updating data. Then it could be that because while you're editing the first page of a wizard, on the last part of it there are some constraint validations because or validation violations because the data is not provided. If they are required field and you didn't provide them, then on submit of the first page it might happen that the validation for these attributes that the user hasn't yet updated are just causing a conflict. Now you can suppress this, for instance, by setting skip validation to true, in which case no validation will happen on the ADF binding layer at all. This might be an unwanted functionality and you want to have something more fine-grained. So you have two additional options. Skip data controls. The skip data control will only validate the current row that you have changed in the page. So that will ignore all other not yet validated changes within a data control or in the page definition file. We'll just look at the current row. But this wouldn't solve the problem of the wizard. Now imagine you have a row that has 100 attributes. So to make it easy for the user to provide data for this row, you want to step him through a couple of screens. And while you're stepping through a couple of screens to update the row, you don't want to have validation failing on the binding layer. And keep in mind, the binding layer doesn't know about partial submits. So ADF Faces supports partial submits where only parts of a screen are updated. The ADF binding layer doesn't understand this. So you have to prepare it for that. And here what you can do is you can create a custom validator object. You extend binding container validator and reference your class in the property shown as custom validator. And then you can set a memory flag and look up the memory flag from this validator. And once the flag says yes, perform validation, then eventual validation will kick in on the binding container. So this gives you the full control over when exactly validation will happen. In very early releases of 10.1.3 actually, up to 11, people had to change the complete life cycle just for achieving this, to control validation. Now, that is now in the page definition file, so even if you're an experienced ADF developer starting very early with 10.1.2 or 10.1.3, this is a new feature that you want to have a look at. Token validation just allows you to handle users resubmitting data by just producing an exception, handling the exception so that you're not writing the same data twice into the business service or the data source. Viewable, it's on the page.def file. You wouldn't use this property as often on the page.def file than you would use this on a specific binding file. If the viewable property is set to false, then the content that is exposed by the page definition file, by the binding container, wouldn't show on the screen. Now the better use case here is if you set the viewable property on an attribute binding that is bound to an input text field or to an output text field. Because if the viewable said false, then by default this component wouldn't render on the screen. So this way you can enforce, from a security perspective, read-only access. So if people are not allowed to view a specific content queried by the binding file, then you can disable that by setting the viewable to false. And the viewable property takes expression language so that you can make this dynamic. So you see, reading the documentation at the end of our developer guides on OTN makes a lot of sense, and it teaches you a lot of nice tricks about ADF. Now, how would you know about binding objects and which objects are doing which or providing which functionality, what they're providing in terms of properties and methods? Well, on OTN we do have an API section where we list all Java documents for different technologies within ADF, ADF business components, the ADF model, ADF binding, DVT, and so on. And this is the first stop where you can look at, where you can access the reference and APIs. Then you go to the ADF model package there and look up the objects that you work with. That's one way of doing that. Another option is, if you have a customer support contract, contact customer support and get a copy of the ADF source code. This would also enable you and allow you to debug within the ADF framework if you're facing a problem that you don't know where it's coming from. Then getting the source code from Oracle definitely helps. But also for learning ADF, look into how is the internal behavior, which objects are playing with which objects when I do a request. But starting with the Java docs definitely is a good first start. So let's look at some of the objects I introduced. So the binding context, as I mentioned, the binding context represents the data binding CPX file. It is a way for you to look up a binding container, and the current binding container can be looked up from the binding context in a call to get current entry. So you never ever have to think about what could be the active binding container. Yeah, so you can just directly go for it by requesting the current binding entry, and then you get the active binding container to work with. Another information exposed by that object is the data control. So you can look up data controls, you can access data controls, you can manipulate data controls. This is what you can do through the binding context. For expression language, the binding context is accessible through the dash data. Well, the dash data is a not really common way of accessing bindings. First of all, you need to make sure that the binding container is active to access it. So if you access this through dash data and then the name of the page definition file, then chances are that the binding container is not initialized with that data. So it's there, but I wouldn't recommend really going for it as a first choice when you code against the binding layer. There are better options that I will introduce in the next slides. The binding container is a live representation of the page definition file, so everything that a page requires in terms of methods, operations, data, that's all configured through the page definition file for that page, and this becomes accessible in the bindings object. The bindings object by itself doesn't contain any specific data. It's not that you have a binding object for every page definition file. It's a container object that when you navigate from one page to the other is just filled with new content, with new object content and references. Yeah, so it's not that you have one binding object or bindings object for every page definition file. It's just a shelf, a container of objects that you can then work with. The bindings object is accessible through expression language, where you use the dash bindings. And if you look in some of your page sources, you will see that the dash bindings is used a lot. On every component, every value reference addresses bindings dot, then the component binding, attribute binding, or hierarchical binding dot input value or something. Yeah. So this is what the bindings is used for. But you can use the same in Java, because everything you can do in expression language you can do in Java. So if as a Java developer you want to talk to the binding layer, then you can access the bindings, and this is what you do with 3 lines of code, as you can see here. First of all, you get access to the binding context. So you call just get current on the binding context. That gives you the current binding context for the application. Then from the binding context, you call get current binding entry, and this gives you a binding container reference for the active binding. And then you can have access to everything. So every data that you want to access, or if you want to perform manual inserts, updates, queries, or whatever, that's all possible through the binding reference that you have. The iterator binding, I mentioned very early that iterator binding is just a way for you to iterate over a collection of data that you query from the business service, no matter where it's coming from. It's from a web service, or if it's from a Pojo or from ADF business components. It exposes a couple of methods for you to play with. You can execute a query, you can find a specific row by a string, by the key string, or you can look up a specific row in the binding by its index. Then you can set the row as current, or you can just ask for the current row. You can remove a row with a key. Based on the key, get access to the data control and to the binding container from there. This gives you full access to the data query from the business service. This is what the iterator binding is used for. And keep in mind, the iterator binding is referenced from all component bindings, from all list bindings, attributes bindings. They all have some kind of reference to the iterator binding to query data, to look up data. To give you an example, if you have a table that shows 10 rows and you select one of the rows, then through the table binding, the tree binding that is used in the page def file, through that binding the iterator will be called in its set current row, so that the table selected row becomes the current row in the binding as well. To access the iterator binding in Java, you start with a binding container. So once you have the binding container, then you can call the iterator binding by bindings.getIterator name, or if the bindings reference is not through the interface but through the implementation, which is DC binding container, which by default I think is returned by get current binding entry by the call to it. Then you can call find iterator binding, in which case you get a typed result, so you don't have to cast it then to a DC iterator binding. It will already be casted by the framework. So this gives you a handle to the iterator binding. The tree binding is used with tables, tree tables, of course, but it's also used internally with some of the DVT component bindings. And you would see if you look at the, for instance, the graph model, that it also has a method that exposes the control hierarchical binding to you. So just giving you access to the actual graph data through the binding in Java. Yeah. So this is a very common class and a very common object, and definitely worth having a look at. Commonly used methods that we call on the hierarchical binding is get root node, just to get access to the root node, find node by key path, because every row there is part of a node. So if you have a tree structure that is 3 level deep, then you have 3 nodes. If you want to access a specific node, then you can do this by a specific key path, and the key path actually is identified by the key string, which on the ADF faces components is a list, an array list. And this array list just is kind of an addressing that starts from the top level primary key to this second root primary key up to where it can find the node that is selected. So just to give you an example, this is a reusable class, and feel free to copy that in your own development. What it does is it just takes a component and first looks at if this component is an ADF faces table or ADF tree. If it is an ADF faces tree or table, then it gets an instance of that, checks if the instance is a table or a tree, to get the collection model. The collection model is the implementation of the ADF faces component model, but this has a method called get wrapped data, and the data that is wrapped in there is the ADF tree binding, as you can see in the line with the red color. So we get geo-control hierarchical binding from the wrapped data of a collection model in a tree and a table. Now, the point I'm making here is that you don't need to know about the binding structure. You don't need to know about the page definition file. If you have a reference to a tree or a table, you can derive the actual binding handle from the component handle. So you don't need to know about the page definition file structure, and this gives you a nice way of creating generic reusable helper classes like the getBinding class that you can put into a static helper class and work with that. To access a selected table row from Java, as I mentioned, you can get this from the binding. For single selection and for multi-selection tables and trees, the process is exactly the same. What you do is you get access to the component, in this case it's a table, and you can get this through the binding property on the component. So if you're a table, the table has a binding property, and this can be used to create a setter and a getter in a managed bean, and this setter is called in the first line here this, so I'm in the managed bean get table1, which is the component binding name that I defined. So once I have access to the table, I can call on the table get selected row keys. Now this is a method exposed on the ADF faces table, and that gives me all the row keys, all the array lists of rows that actually have a selection that the user selected, either by pressing Control and then clicking on the rows, and then I can iterate over this. And the next thing I do is I get the list from this iterator, and the list represents the row key. So this is why I call it key in this example. From the collection model, which I get from table get value, I can get access to the control hierarchical binding, so the tree binding. And one of the methods I introduced on this previous slide is find node by key path. So to get the current selected row, I just call find node by key path on the tree binding, and I pass in the key that I got from the table, and then voila, I get access to my row object. And here I can access the attributes of the row, can update, insert, whatever I want in Java. So everything, as you see here, everything we can do in expression language, we can do exactly the same in Java. To access an attribute binding, this example uses the interface, the attribute binding interface, and it looks up the attribute binding by the name that it has in the page.def file. So in this case, I call bindings get, then I look up for the name of the binding, and I cast it to attributes binding. For attributes binding, it's not that easy to create generic access to the binding layer. There's one way, which is that if you know that the binding value always is attribute binding dot input value, then you could call on a component reference like an input text field get value, and you will get the value expression. And on this value expression would just cut off the input value string, and this way you can derive generically the binding name without explicitly calling for it. Anyway, the most use cases and the most example you find on the internet or within the Oracle documentation uses some knowledge about the naming in the page definition file, as I'm doing here. So I call bindings.get department name, and that gives me an instance of attribute binding. And then all I do is I get the old value, append it with a dash or with an underline, with an underline U, and then I write it back. So I change the value in the binding layer, and I do this dynamically. Yeah, so I can underneath in the model change the value. To execute a method or an operation, I use an operation binding. It's the same principle here. I get access to the bindings object, so the binding container, and call get on it, providing the name of the binding object I want to access. In this case, I cast this to operation binding, because operation binding represents operations and methods. In my example, the method is one that takes arguments. This is why I call it methods with arg. You can give it a better name that better describes what the method is doing. Once you have a handle to the operation binding, you can call get params map on it, and then call put, because it's a hash map. You just put the argument name and the value that you query from a binding or from a managed bean or wherever you get the value from. So you can prepare the method call by filling in values to the arguments, and then at the end you call method with args, in my example, .execute to execute the method to perform the action. Before you continue within the managed bean, you can call methods with args.getErrors size to check if there's any problem with the execution of the method of the operation. If the method returns a value, then you could also say, okay, object value equals, and then method with args.execute. In this case, the object that you specify will hold the returned value. In this case, in my example, there's no value returned, but I'm checking for exceptions, for errors, and if there are errors that you might want to handle, then you do that in the if statement here. Same for list bindings. So if you're working with list bindings, if you have a single select one choice, or if you have any kind of list that you want to get the user selection from, then once it is submitted, either by the user pressing submit or by you setting the auto submit equals true, in which case whenever you change the value in that list, this gets submitted to the model, you can access the exact value the user selected for the list. As many of you know, when you try to get the list value, then it returns an index instead of the actual value that is selected in the select one choice, which is confusing to many developers. But there is a reason behind that. The reason is that in HTML you can only have string values as a value, or representation of integer values and so on. But it could be that you want to access an object. So if you want to access an object, and on the middle tier, once the user selected something, you want to work with that, then an index is pretty helpful. So what we do here in the list binding is that we allow people through our configuration to see a specific label, and they select this label, and this label sets the index of the selected object in the list binding, and we can access it from there. So you see that I'm calling here list binding get selected value. This returns an object. In this case, it's a view row impl, which clearly indicates that I'm working with ADF business components here. But once I have this selected row as an object, I can continue getting attributes from the object like job ID or max salary. If you wanted to get the value of a selection straight, then what you can do is you access the attribute binding that is updated by the list. So if I have a list of values for choosing a job ID, a job title, then this updates my employee records. Now if I access the employee record current iterator, get attribute salary, then I get attributes job ID, then I get the selected value instead of the index. Yeah, but by default we're working with index, and this is how from a list binding in the ADF binding layer you get the selected object, and then you can perform any kind of dependent list of values queries as you want. So let's get back to my example, but now let's have a look into the JDeveloper environment to see how I solved this synchronization between the tree and the input form. So this is the design time view of the example I showed. Here's the tree. I can select the tree within the design time. If you are like me and if you're presenting JDeveloper during conferences, then typically you will experience that the resolution of project is not as good as your laptop could do. There's a selection list in the JDeveloper view that allows you to switch the resolution to whatever the projector supports. In my case it's 1024, and this way the look and feel or the space that you have within the design time is increased. So just in case you have to present this. So what I wanted to show is I have the tree here in the structure window. If I go to the property inspector, first of all, everything I mentioned about bindings, you see bindings, all collections, tree model, is here with expression language. So the value actually references an all collection page definition entry, which is a tree binding, and at runtime this becomes the faces control hierarchical binding, and I can work with that as a JU control hierarchical binding. So everything here is in expression language, but it's accessing the same set of APIs I introduced for the Java access. One important thing to note is that if you want to implement this use case with the input form, then every input form that you use actually has to be built on top of an iterator that is not dependent on the tree itself. So if I have a tree structure like locations, departments, employees, then from a view object perspective, they all should be built on independent collections. And my independent collections are here. I have all locations, all employees, and all departments. And this tree is what I built the forms on. Yeah. To do this, what I have is I used an AF switcher component. And the AF switcher component in ADF Faces is like a switch statement in Java. Allows me to create custom facets. And each facet can be set by setting the facet name property on the AF switcher. And here you see that this reads the value from the view scope, which is a memory scope, and there's an attribute node ref that I populate with the current name of the facet that I want to see. So whenever I click in a tree, what happens is that the selection listener that I created writes a value to the memory, then it partially refreshes the form, the switcher reads the new value in, and then shows one of these facets. And all of these facets contain an input form that I created by dragging one of these collections from the data control palette onto the facet. Yeah. So all I need to do is, with a tree, upon selection, I need to make sure that this value node ref is set in memory, and that then the partial refresh happens. Yeah. So when you go to the tree, there's one more thing that you need to do, and we're still completely in a declarative mode here, so nothing that yet what I've written in Java. There's a pencil icon. If you click the pencil icon, then you get into the configuration editor for the tree. So here you see the tree model, which is locations, departments, and employees. If I go to departments, then you see there is an entry called data source or target data source. When I drag and drop all departments, all employees, and all locations as input forms into the panel, into the facet of the AF switcher, then an iterator is created for each of them. And I can reference this iterator with the tree rule. So when I set the departments view, and to create the departments view, I just press the green plus icon and selected the dependent collection. When someone clicks on the departments view, then this iterator is synchronized with the selected node. And this way, the data that is shown in the input form is always synchronized with the node selection in the tree. Yeah. And you do this for employees view, for departments view. You don't necessarily have to do this for the locations view, because the top level root node will have an iterator representation in the binding automatically, and it will also be synchronized automatically. So this is the preparation I have. So this is all declarative, this is all ADF functionality, nothing that you need to do. But there's one little change that I did, which is for the selection listener. So on the selection listener, you see here is a reference to home bean on tree select. What I had to do is to enforce the synchronization as I needed it, I had to replace the current selection, and the current selection listener definition was bindings dot all locations tree dot make current. Yeah, it was referencing the faces control binding object, and I needed to change this so that I could have pre and post processing working. And what I did is I just implemented the behavior of the make current in Java. So if we look at the Java class that I wrote for this, you see there is lots of documentation in here, and you find this example on ADF Code Corner, and I will have a link to that later on. Here's a method on tree select, and everything that's in Java is just doing the same stuff that the make current expression language would do, just it gives me the ability to put custom code for pre-processing and post-processing in there. And this is the string that it actually replaced. Bindings, all locations, tree model, make current. So the code that's in here just replaces this, plus provides me the extra functionality of detecting the node that the user selected and writing it to memory. Yeah, so I'm getting access to the rich tree. I get this through the event object that is passed into the method. Then, as I showed you on the slide before, I just call on the event edit set just to get a set of row keys, just the keys that are added to the selection. In my case, it's a single selection. Anyway, I go through the iteration. I get access to the key, to the row key as it is in the table. Get access to the tree binding as I showed you on the slides. So get value for the collection model, and then get rep data to get the tree binding. I'm looking up the node binding by calling find node by key path. Pass in the key I query from here in my iteration. So now I get a row which I make the current row. And now the new part for you at least is this line. This is where I'm accessing the type of the binding. So through the node binding, through the JU control hierarchical node binding, I can access a hierarchical type binding that gives me information about the node type. And one of the information it provides to me is the name of the object that it represents. And the name of the object that it represents, in my case, is the location view, the departments view, or the employees view, as you see here. Yeah. So these are my objects, my view objects, because I'm using ADF Business Components. If you're on a POJO model, then these objects are the POJO entities that you're dealing with. So every node represents, in this case, then a POJO entity, and this is what actually this is representing. So what I'm doing here is I say, okay, give me the name of the selected node, and then all I need to do is I just need to put up the node into ViewScope. And because my AF switcher component reads from this attribute that I'm defining here, the node ref in memory, the facet will show the facet with the same name as the object string. And this is how I enforce the switch of the form on selection of the tree. And the last thing I need to do is on the ADF faces context, I just invoke partial page refresh. It looks like a lot of code to write, but as you can see, there's a lot of comments in here. And as I mentioned, you find the code on ADF Code Corner. The link is at the end, so you will see how you get there. But there's a lot of code comments in there. All what I had on the slides in terms of code examples is all used within this managed bean. Okay, so that was part 2 of the binding internals, which I think is a fairly advanced topic, but very useful, and I hope that I did my job pretty well and you understood and understand the ADF binding at runtime a bit better than before. But there's more for you to learn and more resources that we provide. First of all, I already mentioned that you can get the source code from customer support. You just open up a service request on Metalink, indicate the number of the version for the JDEF release that you want to have the source code for. They send you a legal agreement, you sign that, and they return the source code, and then you can play with that. It's a read-only license that you get, so you're not allowed to change it or build your custom version of ADF, but it helps with debugging, with understanding how the internals work, and also to look how we internally work with the binding layer. Then we do provide a lot of information on OTN. There is the JDeveloper Help page on oracle.com technology JDEF. We're providing sample downloads, tutorials, discussion forum access. The developer guides are linked from there, and I mentioned already that the developer guides provide in their appendix metadata overviews of the files that are used, plus the API references, so that you can have a look at the APIs and learn more about the object. There are books out there as well. There are 3 books. 2 are available right now. 1 will become available in September. If you're new to ADF but you're having a background in Java and Java EE, then the first book, the JDevelop 11G Handbook, takes you by hand and leads you through the process of building a full project and an application with ADF. If you like this presentation, part 2 of the binding internals, if you like this level of technology, then the second book is for you. It's an advanced book that deals more with the Java side and the development side on the ADF binding layer and the data controls than purely on the declarative side. So it's kind of building based on the previous book. And the new book that's coming out is an absolute beginner's guide. So if you never ever touched Java, if you have no idea about Java EE, if you're coming from a 4GL background and you want to see what's in for you in ADF, then this is a good starting point for you. So it's all optional, so you don't have to buy books, because everything is within the documentation or on the Blogsphere. Everything is referenced, and there are a couple of documents out there. So 2 links, one to the ADF Insider homepage, just in case that you found this video by Google, so you might be interested in learning where to find more videos like this. It's on the ADF Insider homepage on OTN, or which is referenced in the Oracle homepage. And then we have Oracle ADF Code Corner, which is a page that I'm maintaining where I provide technology related tips, where I'm mostly going to kind of coding, but also try to make sure that I teach you the basics, the reasoning behind, so that you can follow easily and better understand the ADF binding layer. So this concludes my little presentation about the ADF binding internals, part 2. If you haven't seen part 1, I recommend doing this first if you're new to ADF, because that gives you all the foundation. And last thing I can say is thank you for watching this video, and hope to see you back soon on ADF Insider.